In this lesson, you're going to do 1.2. It's called Making Punch. We're going to do ratios and rates and working with mixture problems. Your learning goals, in this lesson, you're going to use rates to make some comparisons, and you're going to use rates and proportions to actually solve mixture problems. Please read the intro with me as I read along. Do you like smoothies? Perhaps one of the best things about smoothies is that you can make one with just about any ingredients. Just throw them in the blender and turn it on. Smoothies can be very healthy too. Try this healthy smoothie recipe sometime. 1 banana, 1 cup of vanilla yogurt, 1 cup of grapes, half an apple, 2 cups of spinach leaves. In this recipe, it serves 3 people. How much of each ingredient would you need to make smoothies for the whole class? So think about that. Think about how many people are in your class, and then think about if this serves 3 people, how many would you need? Stop and write that down and figure it out. All right, now we're going to go to the next page, problem 1. And we're going to continue with recipes, but now we're going to talk about a punch recipe. Problem 1, may the best recipe win. Please read along with me. Each year, your class presents its mathematics portfolio to parents and community members. This year, your homeroom is in charge of the refreshments for the reception that follows the presentations. 4 students in the class give their recipes for punch. The class wants to analyze the recipes to determine which will make the punch with the strongest grapefruit flavor and which will make the strongest lemon lime soda flavor. Their recipes are shown below. Adam's recipe, he has 4 parts lemon lime soda, 8 parts grapefruit juice. Carlos' recipe, 2 parts lemon lime soda, 3 parts grapefruit juice. Bobby's recipe, 3 parts lemon lime soda, 5 parts grapefruit juice. Zeb's recipe, 1 part lemon lime soda, and 4 parts grapefruit juice. So you can see in each recipe, they each have at least lemon lime and grapefruit. That's what they have in there. And what's it mean by parts? A part just means some kind of measurement, but it has to be the same measurement for every recipe, whether it be a 1/4 cup, a teaspoon. If you say a part is just has to be equal amongst all recipes. All right, so I want you to answer question 1. Label out Adam, Carlos, Bobby's, and recipes. How many total parts are in each recipe? So just count them up and write that down. Okay, so check yourself real quick. Hopefully you got that Adam has 12. 8 plus 4 is 12. And then Carlos has 5. 2 lemon lime plus a 3 grapefruit. Bobby has 8. 3 parts lemon lime, 5 parts grapefruit. And finally, Zeb has 5. 1 lemon lime, 4 grapefruit. So in question 2, it says, for each recipe, write a ratio that compares the number of parts of grapefruit juice to the total number of parts in each recipe. And it says, if possible, make sure you simplify. So reduce each rate. So do that now. Look for the grapefruit on top to the total parts on bottom, and then simplify. Okay, so check yourself, and you should have gotten what I have here as far as 8 grapefruit on top, and I just used GF for grapefruit. Hopefully you wrote it out, but on the computer it's just a little bit harder to write. On the bottom would be your 12 total, whereas Bobby's recipe only used 5 parts grapefruit over the 8 total parts. Carlos has used 3 parts grapefruit over the 5 total parts, and Zeb used 4 grapefruit over 5 total. So this is going to lead us into which is the most grapefruit tasting. So think about why would we have done this. We're trying to figure out which has the most grapefruit taste. Why would we have set it up as fractions? Obviously, that's a simple way to compare if we use the total, or if we set it up, I say fractions, but it's a ratio. You want to look at the total, and if there's more grapefruit, the more grapefruit over the total, obviously that's going to taste more grapefruity. So look at your next question, question 3. So it asks you, which has the most grapefruit taste? So explain how you determine that answer. So my suggestion is go back to this problem, problem 2, and look at those fractions. How you use those ratios. How can you compare ratios and fractions? They all have to have what? Hopefully you've thought of a common denominator. So at least figure out what your common denominator would be and compare them. You can write on problem 2 if you'd like, and then put your final answer on problem 3. Okay, so hopefully once you have scaled up to the proper common denominator, which would be 120, you can now see which recipe would be the grapefruitiness, the most have the grapefruit in it. So which has the largest grapefruit? Well, if they all have 120, we could just look at their numerator, and who has the largest numerator? Well, it looks like Zeb does. So let's go back to our question in 3. So which recipe will make the strongest grapefruit? Well, we just determined it was Zeb. And then explain how you got your answer. So I'll let you write that down. But, basically what we did is we scaled up to each recipe to a common denominator of 120. Then we compared our numerators, which was our grapefruit, to see which one had the most in it. Okay, now for 4, we're going to do the same thing now, but now for lemon lime soda. So you're going to look at lemon lime over total and simplify as needed. And then you're going to go look at question 5 to look at which one has the most lemon liminess. So go ahead, I want you to work that problem on your own, and when you're done, start the video again. All right, now, so hopefully you've come up with your scaled up ratios like I have. You went up to 120 as your common denominator. And if you now look at our numerators, Adam's at 40, Bobby's at 45, Carlos is at 48, and Zeb is at 24. So who has the highest lemon lime soda content? Well, Carlos would be the highest. So if you come back to your question 5, you're obviously going to put Carlos and then explain what you did here. All right, so once you've written down your answer there, you're going to want to go on to problem 2. Okay, please read along with me. You are borrowing glasses. Well, first we're going to do problem 2. We're making the refreshments. We're actually going to go into making them. You're borrowing glasses from the cafeteria to serve the punch. Each glass holds 6 fluid ounces of punch. Your class expects that 70 students and 90 parents and community members will attend the reception. You decide to make enough punch so that every person who attends can have 1 glass of punch. How many fluid ounces of punch will you need for the reception? So that's what we're trying to find. We've got to find out how much fluid ounces of punch you need for the reception. So let's go back and look. Each glass is going to hold 6. So each glass, that's important, holds 6 fluid ounces of punch. And how many people are coming? We have 70 students plus 90 parents. Each gets 1 glass. So we got to figure out, based on recipes here, how much each one gets. How much, I'm sorry, not each one, but how much is the total punch materials we need. Okay, so stop the video. See if you can just figure out, based on what we know there, we don't need to know how much of each ingredient, just total. How many ounces do they need? This is a simple problem and not even involving ratios. Just how much do they need altogether? All right, so if you take the 90 plus the 70 people, you get 160 people times the 6 fluid ounces for every cup they're going to get. You need a total of 960 fluid ounces. Okay, so in question 2, let's read the beginning here. It says, previously, you wrote rates to compare parts of each ingredient to total parts of all the ingredients. Recall that a rate is a ratio in which the units of the parts or the whole being compared are different. Okay, so look at number 2. We're going to look at Adam's recipe now. It says determine the unit rate, so the rate of 1, for fluid ounces of punch there would be in 1 part of the recipe if you use Adam's recipe. So whenever you're trying to find 1 of something, that's your unit rate. So you want to know for all parts, for all fluid ounces, determine the unit rate of fluid ounces for the punch there'd be in 1 part of the recipe for Adam's recipe. Try that now. See if you can figure out the unit rate and then come back again. Using the fluid ounces of punch, there would be your answer from 1 for 1 part of Adam's. So go back and look at Adam's recipes, total parts. Okay, so check your math. We know we have 960 fluid ounces total that we need of punch. And Adam's recipe has 12 parts total. So that one on the denominator. To find your unit rate, remember you divide the numerator by the denominator, or just divide out 12. So there's 80 ounces if you divide 960 by 12, and 12 divided by 12 is giving you that one part. So for every part, you need 80 ounces. So that's what I was telling you about earlier at the very beginning of this when we talked about what is a part. A part depends on how many ounces you need total. So here they need a total 960. So you have to divide out the parts for each recipe to get how much you need for one part. So for every part of the recipe, they need 80 ounces. So it's going to be different for every recipe. Okay, so number 3 says how many fluid ounces of lemonade soda and grapefruit juice are needed to make enough punch if your class uses Adam's recipe. So show your work. So I went ahead and started it for you just to kind of give you an idea. So for the lemon lime, we each going to start with this 80 ounces for one part. So you need to go back and look at Adam's recipe, see how much lemon lime, how many parts lemon lime, and then what is your unknown, because you're setting this up like a proportion to solve. So your unknown is how many fluid ounces. Okay, so I'm going to show you lemon lime. So his unknown is X, how many fluid ounces, and then how many parts. So go back and look at Adam's recipe from the beginning. Adam's recipe for lemon lime, so go back to that, was 4. So go back to what we were just working on. And so he has 4 parts. So check our proportion. We have part to part on the same line, and we have ounces, fluid ounces to fluid ounces on the top. Now I want you to go back and do the same thing for the grapefruit, and then solve to see what your X values are. If you look at the lemon lime, and hopefully on the right hand side you said your X was your unknown up top, and you know the 4 parts at the bottom. Okay, so how do you get from one part to 4 parts? Well, you're multiplying by 4. Oops, I see a mistake I made. So if you're multiplying by 4, what do you do it on the bottom? You got to do it at the top. So that should be multiplying as 4 by 4 as well. Can't multiply by something different. Okay, so what's 80 times 4? Well, that's where we get our 320 fluid ounces. Now go back and look at grapefruit. Now that's going from 1 part to 8 parts. Okay, so now we're going to multiply by 8. See how it's coming from 1 part, and it's going to 8 parts. Okay, so we're going to multiply by 8 in order to get that. So if you do that at the bottom, 1 times 8 is 8. You must do it at the top, and 8 times 8 is 640. So for grapefruit juice, to make Adam's recipe for all those people that are coming, you would need 640 ounces. So if you add 640 plus 320, you get that 960 fluid ounces. You don't lose any of those fluid ounces. All right, so you're going to do the same thing on 4, 5, and 6, but you're going to use Bobby's recipe, and you're going to use Carlos's recipe. Well, that's not underlining right. Carlos's recipe, if it'll let me underline there. And finally on 6, it'll let me go there, you will use Zeb's recipe. Okay, so you're going to do all the same calculations. So go back and find the parts for their recipes and figure out the lemon lime, how many fluid ounces of lemon lime and grapefruit juice you're going to need for each one of those recipes. When you're done, you can start it to check your work. Okay, so I haven't done the whole problem yet because I wanted, just in case you were stuck, I wanted to give you a hint here. So first, remember, you had to figure out the unit rate. So we start with that 960 fluid ounces total we need, and Bobby's recipe has 8 parts in it total. So to get the amount in 1 part, we have to divide out by 8, or divide numerator by denominator. And each part, as you can see, is 120 fluid ounces for every part. Oops. Okay. Now, you're going to use that unit rate, remember, to get your lemon lime and your grapefruit. So remember, go back and now, if you needed this hint, now finish and stop. the video and restart when you finish. Okay, so check yourself for Bobby's recipe here. You have your lemon lime. You have 3 parts lemon lime, so you multiply the ratio by 3, numerator and denominator. And so if you multiply 1 times 3, you get 3 parts. 100 times 3, you get your unknown, which is 360 fluid ounces that you will need for lemon lime soda if you make Bobby's recipe. And then grapefruit, you have 5 parts. So you multiply by 5 to get from 1 part to 5 parts. And 120 times 5 gives you 600 fluid ounces. So again, there's kind of 3 steps here. You need to find your unit rate, 1. Then you got to find your lemon lime using that unit rate. So go back and find those parts. And then you have to use that unit rate to get your grapefruit so you can figure out the total fluid ounces. So continue on and do the next 2 recipes and check yourself. Okay, so check yourself on Carlos's recipe. Again, if you find the unit rate, he has a total of 5 parts. So you always have to go down to that unit rate because you got to go start from 1. It's always smartest to start from 1, and then you can scale back up. So you scale down to 1 part, so you know what 1 part equals, 192 fluid ounces. You use that in your lemon lime and your grapefruit start, but then you want enough, there's 2 parts lemon lime. So if you multiply 192 times 2, you need 304 fluid ounces of lemon lime. If you look at grapefruit, you need 3 parts in his recipe, so you multiply 192 times 3 to scale back up, and you get 576. Okay, then go ahead and do your last one as Zeb. Okay, in problem 7, all you have to do is go back to those 4 questions you just did and just fill in the table. That's all you're doing for this part, for question 7. Okay, so now once you look at your table, now the next questions are going to ask you, we figured out before which one had the most lemon lime and which one had the most grapefruit. So look here again, how can we clarify that? Which one has the most grapefruit and which one has the most lemon lime? Well, you can see here Carlos has the most lemon lime when we're comparing to 960 total. And which one has the most grapefruit? Well, that would be Zeb. As you can see, 768 is greater than any other number in there. So the reason we can compare that is why? Well, we're using the same amount of total, 960, just like we had to find a common denominator. So that clarifies question 8 and question 9. So just use what we just said to answer question 8 and question 9, how we confirmed our findings from those questions. All right, so now let's look at 10 and 11 real quick. Okay, so hopefully you figured out, oops, I think that's 1,280, that you would need 320 fluid ounces more punch in order to feed these people. So I didn't write it all out for you. I've only got the math, but you need to answer that question that you would need, how much you need, and how you figured it out. All right, and number 11, will the ratio of the parts in any of the recipes change by putting more punch in each glass? So just think about the ratio of the parts. Does that change? And explain your reasoning. Okay, so hopefully you thought about it. The ratio is never changing, right? Whatever parts to the whole is what you need. But the total amount is going to change based on how many ounces you need. So your ratios are not going to change. Go ahead and answer your talk to talk on your last one and be able to explain how rates and ratios help to solve the problems in this lesson. Good luck and go do your skills practice.